Happy day, Internet. My name is John, and this is my channel, The Intermancer. Let me show you something I've been working on. As you saw on the last episode, if you watched the last episode, I had done my initial bit of code generation for my genetic algorithm system. And I had generated the most basic classes for defining an organism and feeding data through an organism. So I had defined organism, chromosome, gene, data quantum, and a data quantum consumer as an interface. Now, something I needed to change though was I realized that before my data quantum was just having a list of primitive doubles. And what I need is a list of structured data points because, one, I want to identify all of the steps in the computation eventually, so I'm adding a source ID for that. And two, I just know this is going to be more complicated, so I needed to make it a class, not just a primitive. So that's where we are. How did I do it? Well, that was the first change. And the reason I was getting there is because I started implementing actual genes. Let's go ahead and start with the context. I should have done that in the first place. So the first thing I did was I started writing my basic arithmetic genes context, where I describe just a set of single data point genes. Basically, a data quantum comes into a gene chooses one of the data points in the quantum, always the same time, always the same one as it gets fed. Once an organism is configured, all of the genes in the organism always read from the same index of the data quanta that go through. So a single data point gene gets one data point out of the data quantum, applies some mathematical operation to it, and adds a new data point to the end of the quantum and goes on. That operation could be an addition of a constant, subtraction of constant, things basic math applied to a constant, logarithmic or trigonometric functions, or any other number of functions that could be applied to what is it? There's a word, mono something. Anyway, a function that just has a single variable, or a function that's just constant applied to something. All right, I'm calling them single data point genes. There we go. The first thing I needed to do though was I needed to refactor my data quantum here to include a description. To include a description of a data point. So before, as I said, it was just adding doubles, and I went ahead and added methods as I described before. My contexts are, what's the word? They assume Java. They're biased towards Java. They're conventionally Java. So that was really the biggest change that I made here to this. I can't remember if I had this base organism declaration. And it's been ignored. So maybe next time I regenerate this, it'll go away. But really, I need to just change that and get rid of this base organism, and that's what I need to do. I need to get rid of base organism. Anyway, that was a moment of discovery. So after I got the data point in here, I went through a few rounds of regenerating all of this stuff in the COM Intermancer GAIF core organism class. So all of these base classes, I regenerated those. Really, the only one that mattered was the data quantum, because it had that data point in there proper. But then the tests, all the tests had to change more than the classes, right? Because organism, for example, there, I did that again, blast. Organism, for example, only declares, has a dependency to data quantum and just passes that down to the chromosomes. So there's nothing in here that depended on data point, so nothing in the organism needed to be rewritten. However, the organism test had some values that it was adding. And I left these convenience methods in. Looking at this and trying to minimize some of the code changes in the test code is why I kept in those convenience methods in the data quantum that allow for a null source ID in the data point. I don't know if I'll be continuing to allow this going forward though. We'll see. Okay, so that's the whole story around refactoring data quantum to add a data point as an inner class, a static inner class. I might want to refactor that and extract it and pull out a new class. I probably will, but I haven't yet. There you go. So then, as I said a couple of times here, I wrote this new context for basic arithmetic genes, where I describe single data point genes that either apply against a constant or use a method that doesn't need a constant. And let's see how that did. Let's see the addition gene. It has data point value, get data point value. Okay, so it first did this base single data point gene. And I told it to do that right here. And it sets up a lot of things. Applied constant. I promoted applied constant up to base single data point gene, even though that's not going to apply to all of them. Like a trigonometric function isn't going to need an applied constant, unless maybe I shift it. I could shift it and then apply the sign. We'll see. We'll see. That makes sense. That would make sense. We'll shift there. So that's what I'll do probably. That would be logically equivalent, though, to just having some kind of multiplication with the constant and then the sinusoidal thing. So now trigonometric, I'm not going to do a shift. I'm not going to do a shift. Anyway, consume, got this, got my base, and it's an abstract class because it defines this operation method. Defines an operation method that takes the data point value, and then it implements the consume that basically handles all the extracting a value from a data point and passing that down to the operation, and then creating a new data point and adding that to the data quantum on the other side. And all that got generated great, and as before, the test class did what you would expect it to. So that's all good. But then, in the chat log, and some of my chat logs have been a little wonky as far as saving them appropriately in here. I'll get better as I keep doing this. The chat log, the original time, it gave me the base single data point gene. And at this point, I'm still doing these chats in the Copilot window here. My next video, I stopped doing that. We'll see where it goes. And look, it just stops. Everything just keeps stopping. I don't like that. But anyway. Okay, so this is the chat. Close that out. Let's clean this up. Java. And then this can come out. Oh well, don't need to worry about that. Point being, it generated, I don't have it here. Dang it. It's another lost chat. I've been losing a lot of these chats. Oh well, don't have them for posterity. You'll have to forgive me. But the chat, what it did is it generated a base single data point gene, and I had told it to generate data point genes for a list of other mathematical operations, but it only gave me addition and told me, well, if you want to do the others, you can just follow the pattern for the addition gene. And I said, well, that's great. Why don't you go ahead and do that for me? Just generate those. And then it did, just with another little prompt. And I'm really sorry that I didn't recover that so that I could show people. Anyway, here we have the addition gene. As you expect, it does a plus. Division gene does a division. All these things are going off the applied constant that is maintained here in the base single data point gene. We should probably give applied constant an initial value of 1, just so division doesn't go wonky. And then it generated multiplication gene, sign gene. Notice it didn't do anything with the target value there, or the applied constant. The sign didn't do anything with the applied constant, as one would expect. Okay, and the tests came from the same version of tests, same kinds of tests that we saw with the chromosome, organism, and all that stuff. So we look at the addition gene, and it's testing the operation, and it's just feeding the gene a data quantum. It's not creating a whole organism. So okay, I was wrong about that, which is fine. Delta 0 to 1. What is this? I haven't even read this one. Test addition with 0 constant. Assert equals. Interesting. Delta. It's saying 10 within the value. So this is so it handles funny math in the computer. It's interesting that these deltas came like that, which I guess is fine when you're doing tests around double primitive values. Addition, data quantum 5. Awesome. Okay. That makes sense then. All right, and everything compiled. You can see from Gradle when I do the build successful. I should have done that just before I started recording, but it all worked out. I think that's it for this episode, YouTube. I have already coded a little bit farther along, and I'm really enjoying this, so I'm looking forward to seeing where it goes. Thank you for your time.